640 feet. We will take 5 readings for density and in this video, we will be discussing test sections and their construction. A test section should be 1/2 mile in length, which is 2,640 feet. We will take 5 readings for density and moisture spread out across the area. The nuclear gauge should be in backscatter position and in 1-minute mode. Because we are only taking 5 readings over 1/2 mile, we need to be sure that each reading we take is representative of the whole area. The way that we go about doing this is through random sampling. Random sampling means that all locations have an equal chance of being selected. We do this through a random number table. Additionally, we will divide our test section into 5 evenly spaced sublots. Let's look at an example problem. The contractor has applied the dense grade aggregate layer to the right lane of a 2-lane roadway beginning at station 25 plus 25. Using the numbers from the random number table given below, calculate and determine the test location for each density and moisture reading for this test section, which is 12 feet wide. Remember not to test any closer than 18 inches to an unsupported edge. Here is our example test section, which is 2,640 feet long. To divide this into 5 sublots, we would divide by our 5 tests, which means that each sublot will be spaced out by 528 feet. Our beginning station number was given to us as 2025, which means 2,525 feet from a starting point. To find the beginning point of our next sublot, we simply add 528, which would give us 3,053. This would be the station number at the beginning of our next sublot. We would then take that number and add 528 to that as well, which would give us 3,581. This would be the beginning station number of the next sublot. We would continue this method across the test section until we reach the final station number, which in this case is 51 plus 65. We can then take these numbers and fill them into the column that says station number at the start of each sublot. Then, taking the numbers from our random number table, we can fill these in under distance from start of sublot. Next, we can add the distance from the start of our sublot to the station number at the start of each sublot to find the station number that will be our test location. For example, in test number 1, we are at station 25 plus 25. We will add 181 to that number, which will give us 27 plus 06. We will continue this down the rest of the column, and finally, we will fill in the distance from our reference line in the final column. Now that we have identified our station numbers, we can fill them into our TL55. For this problem, we will assume that we are in the westbound lane. Once tests are taken at each of those locations, we can fill those into our table and solve for an average. We will also take moisture readings at each location. Finally, to determine whether or not our test section passes or fails, we will need to look at our individual dry density requirement and our average dry density. Our individual dry density requirement states that each test must be greater than 95% of our control strip average density. Looking at these numbers, we see that each is greater than 128.5, so each would pass. Finally, for our average dry density requirement, we need our average to be greater than 132.6 pounds per cubic foot. In this example, our average is 135.4 pounds per cubic foot, so that would pass as well. For a test section to be valid, all moisture readings must fall within the optimum moisture range, and each individual dry density should be at least 95% of the control strip dry density. The average of the 5 dry density readings should be at least 98% of the control strip average dry density.